Today everyone, I'm going to show how to solve problems about transformers, induction motor, and synchronous motors. We'll proceed to solve about the problems of transformers. So number one, that's the problem, and the given data, which is the capacity rating of 75 kVA and the power factor of 0.8. The total apparent power is equals to the square root of 3 times the given rating, square root of 3 times 75. So, square root of 3 times 75 is equals to 129.9 kVA. Now, we will proceed to the maximum load is equals to the total apparent power times the power factor. So, we have 129.9 times the given power factor, which is 0.8. So 129.9 times 0.8, we have 103.92, or approximately equals to 104 kilowatts. That's the answer to problem number 1. And we'll proceed to the problem number 2. Problem number 2. The given data of problem number 2 is equals to HP is equals to 250 times the power factor of 0.7 and the efficiency of 0.9. So first we will compute the input power, P out over the efficiency, but we don't have the output power, so we'll compute first the output power, which is the given horsepower times the 0.746, so that we can have the kilowatts answer. So the given HP is 250 times 0.746, 250 times 0.746, we have 186.5 kVA. So we'll proceed to the total apparent power. Before we compute total apparent power, we'll proceed to compute the input powers, because we compute the output power. After computing the output power, which is 186.5 kVA over the given efficiency of 0.9, 186.5 times 0 divided by 0.9 is equals to 207.2 kilowatts. That's our input power. So we compute the total apparent power, which is the input power over the power factor. We have our input power of 207.2 kilowatts over the given power factor of 0.7. So 207.2 divided by 0.7 equals 296 kVA. Now we can compute the rating. So we have the apparent power over square root of 3, 296 over square root of 3. Our final answer is 170.9 kVA. That's our final answer for number 2. Proceed to the problems about induction motor. So now we proceed to the induction motor problems. So number 1, we have a data of the number of poles of 14, frequency of 60 cycle, and slip of 5% or equals to 0.05. So the speed is equals to 120 times the frequency over number of poles times 1 minus the slip. 120 times 60 over number of poles of 14 times 1 minus the slip of 0.05. So we compute 120 times 60 over 14 times 1 minus 0.05. So we have 488.57 RPM. That's the final answer for the question number 1 of induction motor. So we proceed to the question number 2. We have a data of horsepower of 750, efficiency of 0.95, load voltage of 460, power factor of 0.85. First, compute the input power. But we don't have output power, so first we will compute the output power. HP times 746 so that we can have a watts answer. 750 times 746 we have 559500 watts. So we can now compute the input power. 559500 over the efficiency of 0.95. 559500 over 0.95. We have 588,947.36 watts. That's our input power. So we can now compute the current rating. Input power over square root of 3 load voltage times power factor. Input power is equals to 588,947.36 watts over the square root of 3 times the load voltage of 460 over the power factor of 0.85. 588,947.36 divide square root of 3 times 460 times 0.85 is equals to 869.64 amperes. That's our final answer for the question number 2 about induction. So we will proceed to the problems about the synchronous motor. For number 1, we have a data of horsepower of 75, efficiency of 0.92, load voltage of 600, and the power factor of 0.8, armature resistance of 0.05 ohm. So input power equals to output power over the efficiency, but we don't have output power, so we'll compute first. Horsepower over 7 times 746, 75 times 746, 559500. So now we can compute the input power. 559500 over 0.92 608,152.217 watts. That's our input power. So we can now compute the current rating of input power is equals to square root of 3 times VL times power factor. Input power is 60,815.217 times the square root of 3. Load voltage of 600 times the power factor of 0.8. So we have 608 5.217 times square root of 3 times 600 0.8. We have 73.15 amperes. That's our current rating. Now we will compute the power developed. P stator minus 3 times the current rating times the armature resistance. We have 6 60,815.217 times 3 minus 3 times 73.15 squared times 0.05. We have 6815.217 minus 3 73.15 squared times 0.05. We have 60,012.57 kilowatts and so we will put it in kilowatts. So we have 60 approximately equals to 60 kilowatts. That's the answer for question number 1. Now we will compute the problem number 2. We have a data of voltage of 220, current of 25 amperes, power factor of 0.86 and resistance of 0.4 ohms. P stator is equals to Vp times Ip factor. So we have 220 times 25 times 0.866. We have 220 times 25 times 0.866. We have 4,763 watts. So we can compute the power of copper loss of equals to Ip squared times Ra. 25 squared, so times 0.4, which is our resistance. So 25 squared times 0.4 is equals to 250 watts. That's our copper loss. Now we compute the efficiency. Efficiency is equals to power over stator power. Stator power minus copper loss plus stray loss over stator. 4,763 watts for the stator power minus the times of 250 plus 450 over P stator, which is 4,763 watts. We have times of 250 plus 450 for 4763. We have 85.3% because we multiply it to 100, so that we have the final answer of the percent. That's the final answer for the question number 2 of synchronous motors.